Okay, everyone, I'm going to do a video about historical simulation on market risk, right? Market risk of Var, and basically talk about extreme value theory. I did a recording a while ago, however, I realized there's an issue. I have to do it again. That's a beautiful part of it. So Monte Carlo simulation, even CFA level 1, right? You need to compare Monte Carlo simulation and historical simulation. Second level goes into depth, right? What is Var, and then there are multiple ways to do it. What is parametric? I didn't talk about it, but you should know it already. Like if you know a normal distribution, right, and then you have a zero as a mean, and then you have a standard deviation here. This is parametric. Okay, is that making sense? So you kind of give them a distribution function and then identify from the function itself. Then talk about historical. Monte Carlo simulation is just computer based, right? You just either from parametric or historical, you just use a computer to generate multiple times. And then FRM does require extreme value theory. Even CFA level 3, okay, historically test Var calculations a lot. Didn't really see those recently on even the second level of CFA, but doesn't mean it will not happen in the future. Okay. So historical simulation collects data on daily movement. Okay. In the first simulation tray, assume that the percentage change in all risk factors are on the first day. So what does that really mean? Okay, let's say if you have day 1, day 2, day 3, right? And then that's 3 days ago. Okay, like this is 3 days ago, 2 days ago, 1 day ago, right? And then we are here today. If you day 1 to day 2, you have a 2% change. Day 2 to 3, you have a 1% change. And then we have a price, right? Let's say today, how much would that be? We will just look at day 3, right? Day 3's price times 2%. 1 plus 2%. How do we get the 2%? We get it from here. Okay, is that making sense? We assume that today the percentage change will be the same as day 1 and day 2, which is 3 days to 2 days ago. Okay. Then what about the next one? We just assume 1% change. And then we always come back, right, from day 3. Okay. So is that making sense? Just assume a percentage change. This is called a historical, right? This is historical simulation. Be like, this is crazy, right? It doesn't make sense. No, it does not make sense, but this is just one way to look at what we can do to predict the future, okay? And you will say, maybe 2% and 1%. I will probably trust more about 1% because it's closer, right? And then I will probably trust less about the 2% because it's more days ago, right? Older, basically. It makes sense too. That's why they choose something called weights. Okay. It also makes sense. Why? Because if you think about 5 years ago the market versus today's market, it can be very different. Because 5 years ago it's under President Obama and we have no trade war. Today it's under President Trump. We have a trade war, right? Certainly you will differentiate those. And then we do talk about percentage change, and sometimes they have actual change, right? Sometimes interest rate, you just look at like if it's 2.5% compared to 2.25%, we will focus on maybe the real value change, right? 25 basis points. And then we have sometimes credit spread and then volatility, right? We just focus on the value change other than percentage change. It's your choice. Okay, you can choose it, and then you can look back, right, to see whether those have better outcomes. Okay, so this simply summarizes percentage change and value change and actual change regarding using mathematical formulas. So we're gonna look into those by using Excel. So you have $10,000. Those are the money you have in those 4 indices, right? And then we have like from 2006 to 2008, 500 trading days. And then how can you, let's look at Dow Jones, for example. How do you predict the value next day? We just assume that the next day, right, our return comes from this. What is the return change from August 7 to August 8 in 2006? We assume that it will be coming here. Then we can just add those numbers by the percentage to get a prediction. It's called a historical simulation. That's exactly what it's doing here. Again, it does makes no sense a lot of times, but it's called a scenario, right? Now it does give you the loss number, so it gives you an idea of how much you can lose in general if the history repeats itself exactly. Then you can just rank them from the worst to not to the gains, right? Then you can count 99% VAR and then expect shortfall. So again, this 1%, right, times 500, we have 5, right? Count to the 1, 2, 3, 4, 5. So this is your VAR, right? And then for the expect shortfall, that's worse than VAR, right? You just have only 4 observations, and then you just equally divide them. It's just simply average them. And then we have those losses, right? If you have stressed, like if you just put all the bad days together, how bad it can be, it's called stressed, right? That's what regulators want. They want to know how bad it is, okay? And then you can also have stress, expect shortfall. Again, we talk about like data a long time ago should not be treated the same as the data yesterday. That's called weights, okay? So a really general weight is called exponential weights, okay? So we just weight them by lambda, okay? How many powers it has. Called exponential, right? So the more recent data will have higher weights, the old data will have lower rates. So that's what the weight is. I will go over those with you guys in Excel, and then you can just accumulate them, right? So this is when you reach 1%. That's why we are going to have a new VAR. Okay. Remember, this is older VAR, right? And then this is a new VAR. You guys can see that you will make a difference in your VAR and expect shortfall calculation. And then again, this is a video. If you feel like it's too fast, you can always pause and then try to think about it. A bootstrapping method, it's just using computers, right? We have 500 days, right? 1, 2, 3, 4, 5. 500 days. This is day 1, day 2, day 500, right? This is a history we know. And then bootstrapping tells you, so I want to simulate a new day 1. How can I do it? I just randomly draw, right? I have many items here. I just randomly draw one to give it to day 1. Then I draw 1, right? And then I need to replace it back. Okay, I will just put it back and then draw another one for day 2. What does that really mean? It means day 2 and day 1 can draw from exactly the same day in the history. Okay, they can draw the same worst day from the history if you do it many times. That's why they do 1,000 sets of 500-day simulations. Okay, you draw 1 day, give it to 1, or you don't need to draw from day 1. You can draw randomly. Okay, this is just random draw. You draw randomly, like from day like 100, and give it to day 1. And randomly draw another one. It can be another 100, or it can be like 99 days in the history to give it to day 2. It's called a bootstrapping method. I do a lot of research on those. If you have any questions, let me know. And let's talk about extreme value theory. I think this is a really useful theory, but the math behind it is very complicated. The idea is fairly simple. What they say is, so these bad scenarios, right? Those are the tails, right? Those are the events we care about. What they say is, those conditional distribution on the tails greater than your threshold, your VAR, right? Pick a VAR, tends to converge to generalized parameter distribution, and then they have a function for it, okay? Function for it, for this distribution. They can use a model basically to model those bad events. And then that's all I have on lecturing, so I will just delete this, and then we will just move to Excel illustration, okay? So this is the Excel illustration. This is the data, right? We have 500 trading days of data from Dow Jones, and then FTSE, Canada, Nikkei. The first thing you need to do is you need to convert those value to US dollars, because those are in foreign currencies, okay? Then you can just look at the simulated strategy, right? Just like what I mentioned, just assume the historical percentage changes happen again what are the new values of those. Then you have portfolio value, and then you have losses, right? Then how bad it can be. You can just rank the worst case scenario and how much you can lose. With that, you can get a var, right, and expect shortfall, just like what we showed in Excel, in PowerPoint. You can also assign weights, right, just like I wrote here. It's weighted this way, and then you can just assign a lambda value. You don't have to assign the same value. You can just assign a different value. It will just change, right? And then again, you can see that the closer it is to today, the larger the weights it has. Okay, and then if you add all those weights together, it will equal to 1. Then you can just rank those. It will give you that. You don't have to use the same weight, right? There are many ways you weight it, right? Like right here, you weight by the volatility. What it says is, if you have some losses in a really bad day versus like overall market is extremely bad, like Christmas Eve in 2018, the market was down like 4% that day. Okay, if you lose some money, you cannot treat it the same as like a really common day. Like today, the market is kind of flat. If you lose a lot of money, you should treat those two differently. How do you treat them differently? You just need to divide those volatility by each other and adjust accordingly. That's why they adjust the weights, right? Then you can have a different var and expect shortfall. Okay. The math looks a little bit intimidating, but the whole idea is fairly simple. Okay. Don't get overwhelmed by like Excel and so long, right? Some math. It's fairly simple. For extreme values theory, they do have a distribution function. That's why you can always collaborate those parameters using the data you have, and then with that, it can give you value at risk, and then confidence interval and expect shortfall. They have mathematical formula provided. You don't have to remember those. You just need to remember it's the tails, and then it can be generalized using a distribution model. Okay, so that's all I have for today.